You gotta right click onto where you want it to paste and then click the clipboard. Okay, so we'll go ahead and get started. I think we're like less than a minute in. So this week, we're gonna go over network technologies. This is the foundation for security, right? Outside of this class, I recommend that you take a networking class or multiple. 40A is part of the IT technician series. While it's not required in the cybersecurity specialist or the analyst certificate, I do highly recommend that you have strong networking skills because that's where you're gonna see attacks. That's where you're gonna be able to monitor. If you are an RTC student, you can take the 26 series, which is Cisco oriented, 26A, 26B, 26C, and it goes all the way till the E or the F. In Moreno Valley, we offer 40A as the Network Plus class, and then you can take the 40B, which is the routing and switching class. I personally feel like those two courses play a big role, or the concept of that play a big role in the security career and also my career. So, and the Network Plus, it's always good to have that certification because it's useful when you troubleshoot network or you work with network administrator, you need to have the knowledge. Okay, so let's start off with talking about attack, and we're gonna come back in the next couple of weeks. We're gonna spend a little bit more time in like different areas of threats and also looking at risk. Kind of similar to some part in ethical hacking, but for this class, it's gonna be the introductory, so I'm not gonna get in depth in a lot of things. I'm pretty sure some of you probably see my video on brute forcing. So we might do that, and we might use a little bit more close to date technology, because I've previously shown students how to use Cane to do brute force. So we'll come back to the attacks, but first we're gonna talk about sniffing attack. My ethical hacking class just went through a lecture session on sniffing attack, and they're looking at network, and we're gonna touch a little bit on that today. So everything in the network can be seen as packets. As you know, like how we ship things to people, right? We put it in a box, we put a label on it, we drop it off at the shipping place. In the network environment, your data is broken into pieces, okay? So, if, for example, I can ship a bicycle to my friend, and that bicycle is broken up into several boxes. A box will be a handlebar, another box will be the pedal, the third box will be the wheels, and your data is treated that way. It's broken into various sizes and packets, and it streams through the network, and then it would go through multiple networks until it gets to the destination. And very much like the label, your data has headers that would contain who it's coming from and where it's going to. So in a sniffing attack, what happens is the attacker would look at your network traffic. For example, I can connect to your wireless network, and I can see all the activities that are happening on your wireless network. Let's say that you're uploading a photo or a video. I would be able to see that. I would see that that system is sending some kind of information that's media related to the server that's storing that video or that image, right? So ultimately, it's really sniffing out the header for what is being sent. And then on that, it would have some kind of protocol. And whenever we say protocols, those are rules that the system agree on to how it's going to communicate. So for example, if I'm connecting to a web server to access a web page, it would use HTTP or HTTPS protocol, right? That's the type of protocol that the system agreed on to communicate, to negotiate. Oh, the server is going to give me the website, right, page. That's what I'm going to see on the screen. That's going to be presented to me. So hence, what's going to happen is when they're sniffing the traffic, they're going to be able to see what is being communicated across the network. And so with that, they can capture the data. And data is essential for the attacker because they're able to obtain information like a session ID. Your system, when it communicates with another system, if it's securely communicated, it establishes a session, right? And it uses the session ID to negotiate that. So the attacker can step in and say, hey, I'm gonna impersonate the system A that was communicating with the system B. I'm gonna pretend to be A now, and I'm gonna be able to obtain the data that was intended for the system A. So sniffing can go a long way. And you can also get things like password. Sometime if it's not sent with secure protocol, you can see that in plain text. Plain text, that's what we read right now, right? Plain English. That's what we can see. So things like, you know, sensitive data can also sometimes be seen in plain text. So in the first question, it asks you, how can I perform a sniffing attack? Well, that's pretty easy. Most of the time, you're going to see that there are network scanners that we use to monitor the network. So that means that I can run Wireshark, which is what you will be doing later. I would be able to see all the activities that are happening on the network, right? So I can see what packet is being sent back and forth. I can also see, you know, which systems are communicating. But before leaving the network, I have to be able to go from, you know, my system to the main backbone of the network, which are the switches, the routers, the servers. So you would see multiple type of communication back and forth. So they would use network protocol analyzer, or what we call a scanner. So I'm going to add in a word, because scanner can be many types of scanner. We can say network protocol analyzer or scanner. And if you just simply search Google and say, what is the network protocol analyzer, right? It's going to give you some definition and also simply what we see, what I just talked about, and it would give you some of the common. So in the industry, you would often see things like Wireshark, right? So Wireshark is more of a passive scanner. What it does is like listening in the background, right? All I have to do is I just need to connect to a network. That's my target. And then I would run that particular software. Remember why I said this particular type of job that you're going to be doing is just knowing how to utilize the proper tool, right, at a certain time, and you'll be able to interpret the outcome from that tool. So now some scanners are active scanners. That means that it's going to try to send packets, right? So Wireshark is kind of like you are standing in the background. It's the wallflower, right? It's looking at what's passing by as traffic. But there are other scanners that it's going to also intervene, right? It's going to step in and it's going to say, I'm going to just send out packets to see which systems are responding to me. And if those systems are responding to me, then I can get its information. So those are active scanners, okay? So some of the applications that you can use for scanning Wireshark, we mentioned that. You can also find EtherCAT. That's just another software for network protocol analyzer. That's just like a different type of software that you can get. So there are variations, there are many. You can also use Snort. Snort been around for a long time, right? They are the people who created Snort. They own security companies now. So there are technologies that have been integrated for a long time and then improved over time. So those are just a few that you can find. Any question? So here I listed some of these, but you gotta know that some of these are just attack tool. Some of them are active and some of them are passive. So if you are, let's say that you're an ethical hacker and you want to be more stealth, right? You've gotta know the tools that you're gonna use that are more stealth. But sometimes the stealthy tools are not gonna get us what we want. So we have to use more active tools. And in that case, when you use active tool, all the detecting system, like intrusion detection system, right? Those are the alarm system, it's gonna sound, okay? So you have to know what kind of tool that you need to use and when, okay? So normally, an attacker or an ethical hacker, they would start with a stealthy tool. Then they're gonna get some information, and if they need to get more information that requires the active tool, then they're gonna use those scanners, okay? All right, so, now TCP dump, very popular, you can use that in Linux. There's Kismet, Kane Enable. Kane been around since the 80s. This tool is a lot of time known for password, or keys brute forcing. It is an old tool. There are other tools, but you can find Kane has the capability to do networking. But when you download Kane onto your Windows, your antivirus software will try to lock it away. It sees it as a threat. Just so normally I recommend, so I got a comment on YouTube, they're asking me like, oh, I can't run Kane on my regular PC. And I said, well, if you disable your antivirus, you might, but I don't recommend using a lot of the security tools outside of the virtual machine. Even though we know that there are attacks from virtual machine to regular, but it is more contained. And you can always delete and remove it and zero out the disk, okay? So there's DNS sniff, that's mostly for DNS, which is domain name system, right? So there are others. We'll come back to a section where we would do. So denial of service is to cripple the system so it can't respond. A lot of time, the easiest attack is going to be to the web servers because there are more than 9 million web servers around the world. So to connect to a company, sometime you would need to connect to its website. So, web servers can sometimes, they are connected to the network, but a lot of the times they are on the demilitarized zone. It's kind of like an area before the private network. And we would secure that with a lot of different type of firewall. We'll talk about design shortly, okay? And then you can do poisoning attack. So let's talk about the protocol. I'm going to put the answers up as I go through these. So for question 3, it says, what protocols are often used in denial of service attack? And often that you would see UDP. It stands for User Datagram Protocol, right? And the User Datagram Protocol, it's different than the Transmission Control Protocol in that, maybe I need to zoom in 200, sorry, to make it bigger for some of you. And I will close this. So the User Datagram Protocol, it doesn't need any kind of confirmation, okay? So TCP requires that there is an acknowledgement that it's ready to receive. So if let's say that I'm using TCP and I'm sending my data to Gabriel, I gotta make sure that Gabriel acknowledges that he's ready to receive data. So TCP is gonna take a lot longer to establish that connection compared to UDP. Not a lot longer, but longer, right? And the analogy for this is when you send UDP, it's kind of like you just ship a box and you don't care whether it gets there in 5 days or 30 days or the next day. You just send, right? When it gets there, right? Sometimes you just don't want to pay for the extra shipping fees. With TCP is like sending a certified mail, right? Or a box that you want that signature verifying that they are to receive. And then before that, you would pick up the phone and you would call that person and say, hey, I'm sending you a package. And they say, okay, I'm ready. That's how TCP works, right? So it needs to acknowledge that the receiving system is gonna be ready to receive, and then it sends, okay? Compared to UDP. So this is why it's preferred as a form of traffic, is because they can send massive amount to cripple that system, right? So let's say that I'm asking you 50,000 questions at the same time, and you're too busy to respond to me, right? Or I can use a lot of bots to send you 50 million questions at the same time, and the server just got so occupied that it wouldn't know what to do, and that's how they basically perform either denial of service or distributed denial of service. Distributed just means that they're using many systems to attack that target, whereas denial of service is system to system, but requesting many times until it becomes flawed, right? It's just not able to respond. So the delivery assurance, remember that signature that sign on the package is TCP, Transmission Control Protocol. So with that, when you see the network traffic, if you see SYNAC, right, that's usually TCP suite. And then UDP, we would do that for fasting. So when you're watching videos, right, when you're listening to podcasts, a lot of times you would see that UDP traffic is being used for those type of packets. They're audio, media based, and so on, because they need to stream fast. And so with that, you would see that the header for UDP is less with content. So when you look at that label for UDP, right, the header, it would show less information because it doesn't have to have, you know, the some additional thing with acknowledgement and assurance. Any question? So we must, to be good in security, we must know networking and we must know protocols and port number. I'm not kidding. Okay, because ports are like doors to the system. Okay, how many doors do they have open? It's like if you want to enter someone's house, you want to check out, oh, is their front door open? Is their side door open? Right? So that's what the attacker does. They scope out the area and the environment by listening, by scanning. Okay, another protocol that's important is address resolution protocol, your ARP. Basically, it ties the network address to the physical address. It's kind of like this. ARP works like this. It translates a legal name to a nickname. Let's say that you have a legal name outside. Everybody, the world knows you as the legal name, right? That's the IP address to the system. The system is known to the world with this IP address. And then inside your house, you have a nickname. Everybody calls you that, right? Only in your house that you have that name. So ARP takes that legal name and ties it to your nickname, so that way it can when the traffic comes in, it would know from the network address to where that system physically exists, right? Because the router brings the traffic to the network, right? The switch is an appliance that takes that traffic and take it to the right area. Think of it like the router takes you to the exit from the freeway, okay? After that, the switch is gonna take that traffic and it's gonna go down. It's gonna navigate it to which street or which neighborhood your house is at. Okay. So that's how the network connection really, you know, that's how the traffic gets you to the system. So that means that we have to have a set of rules where the system, the switch would have a table where it says that, oh, this MAC address belongs to system A, and it is at this segment, like it's on the street, okay? So the switch is gonna say, oh, it's intended for that system A, so I'm gonna send it to another switch that's managing that segment. And that's how it gets to that system. Okay. All right. I'm going to come back to the notes. Okay, so here, now IP is basically for addressing, right? Internet protocol. It's used for addressing. There's two versions. IPv4 is version 4. So all, whenever that we use the octet like this, 10.0.0.1, you see the 3 period like this. Those are called the version 4 address. And each of these are octets. They're 8 bits each. Okay. And then with that, they would have what you would see. So think of this like your house address that's registered with the city, right? And then your house would have a zip code. So the router, it doesn't care the specific, it only cares about the zip code area, okay? It's like, it just needs to navigate you to that exit, right? That area, that region. And then the switch is going to come in and say, oh, that IP is correlated with this actual physical system. So ARP is when it's going to do that. The version 6, it uses hexadecimal. So you would see a string of addresses and you would see colon. So I'm going to do this real quick. So if you want to see your address, open up command prompt by doing CMD, right? In Linux, you just use IP space address. In Windows, you do ipconfig, and simply that is going to give you the summary. Okay, so this pops up, and you got to pay attention to your adapter, right? Your adapter is different than mine because I'm on wireless on my laptop, and it tells me this is my version 4, right? The subnet mask, remember what I said earlier? That's the zip code that we're talking about, right? And then the default gateway, that's your router IP. So at home, when you do this, you would see 192.168.0.x, like 7, 10, whatever, right? It depends on when you join that wireless network. But the router, the default is 192.168.0.1, because administrator, the way that we design it, 1 is the first system that you see from the outside, right? That's the gate to your house. Okay, and then .2 would be the next one, maybe a firewall for the internal firewall, the edge firewall, and so on. Any question? Okay, now another, we'll do a little bit of command. If you do all, you're gonna see everything else. So it's a little bit more detail. So what command did I use? ipconfig space/all. That's in Windows, that's what we use, ipconfig space/all. And this will give me more information. When did that system obtain an IP address? It's a temporary address for a certain period of time. This is the way that we can recycle IP address in a large network like this, because you might shut down your system, this computer, for 2 weeks. We can give the IP back to another system so it can use. So that way we can recycle some of the IP address, because we did run out of version 4. Public addresses now, I think most of the time if they have IP version 4, it's because they had reserved it. Still, with the amount of Internet of Things and all the smart systems out there, right, we have to use version 6. So with the version, so there is DHCP here. So as you notice, right, my physical address is what's called the MAC address, media access, right? So this address is associated with my IP address, the preferred address, using ARP. So ARP normally is just a table. ARP table would contain IP to MAC. Okay. Any question? All right, so now you know how to find your IP address using command line. Now ICMP is ping. So when do you use this? You use it to test to see if system is alive, connected, right? So I'm going to show you how you can ping. So in your command prompt, you can do a ping space, and then you can do 127.0.0.1. So you're using a loopback address. That means that you're pinging yourself. So if that system is connected, it's going to reply 4 times. In Windows, it's only sending 4 packets. So think of it this way, like you knock 4 times, and if someone is home, they're going to say, I'm here, I'm here, I'm here, I'm here 4 times, right? Now, not all network, they enable this because you can ping someone to death, right? That's a Smurf attack. So in Linux, if you type ping in the address, it's just going to keep pinging until you tell it to stop, okay? But in Windows, the way the OS is designed, the command line, it's only going to send 4 packets. Now, if you see no reply, it's going to tell you that right here. So when I'm using a loopback address, I'm basically knocking on my own door, right? I'm checking to see if my own system is connected. Now I can ping another address. So let's ping their DNS server real quick. See if they turn it off. Of course not, because it's working, right? Otherwise I can't join the domain. I cannot connect to their network. So that's how you can see if system is talking or not, right? By pinging it. And that uses ICMP. This one, Internet Control Message Protocol. So whenever you see ICMP, and there's version 6 and version 4, right? So you can set your firewall to block ping, and that's normal. Okay. NDP, this is used to discover nearby system. Often you would see network devices like the routers or level 4 or 3 switches will do that, where it acts as a router. So it's kind of like, oh, who's nearby? So I can pass the traffic to you, right? It's kind of like, you know, running a marathon, but not your teammate, but whoever that's nearby, you just pass the baton, right? So the way that this works is just detecting, and you can have it auto-configure for different version of addresses. Real-time transport protocol, this is used for audio and video purposes, including push-to-talk. This was popular back in the 90s and early 2000s, right? Where you press a button, you talk into it, and then it sends. Video conferencing like Zoom, very popular. Streaming media, voice over IP. Your phone uses IP. I think all of us are using voice over IP now. Secure real-time transport protocol. This is for using encryption, and it encrypts the message through our when it sends through RTP. So you do have more security because it's using encryption for integrity in data transmission. So if they're trying to do man in the middle, and then trying to capture your data, modify your data, it will be harder to do that for replay attack. Today, we're going to use file transfer protocol. This is used to distribute files, upload and download. Okay, so FTP servers are still around. Mozilla runs one of the larger FTP servers. But if you are planning to offer FTP service, I recommend you use secure FTP, which, you know, has encryption. But the default for the TCP, you would see that it's port 20, and then you can also use port 21 to control signal. Now, if you want to use UDP at port 69, you can use the trivial file transfer protocol. It is a variation of file transfer protocol. Okay. And you can chunk that into smaller data. SSH is very popular, right? All my networking students, they go through and they configure things using SSH. So I can remote into the switches in the router using SSH. It's called secure shell. It's a way that we can connect system to system directly without, and in the transfer, it uses encryption key. So your text is not transparent, right? You want to protect the data that's transmitted. TLS is supported with your HTTPS. So whenever that you log in to pay your bill, to fill out your financial aid, when you see HTTPS, right? Now the integration with that is it's using transport layer security. So before they were using SSL, but SSL has issues even with the later version. You rarely see websites now that supports SSL only, right? You would see SSL with TLS or TLS version 3 or more. So when you do assessment for web application or web development, you often would look at this area. And then IPsec is how you can create a virtual private network that basically a protected network where you can access. And so it uses encryption for the traffic. And I snip a little bit of the header so you can see it is very different than your regular non-encrypted traffic, where you know how your headers. So it creates, it adds in some additional field, and that's used for encryption purposes. Okay, so for 7, it asks, or for 6, it asks you what protocol is used to stream video over the internet. We learned that it is real-time transport protocol, your RTP. You see this is support in Windows environment a lot. And a lot of like the media stream-based application, it requires this particular set of protocols, the rules, on how the system is used. So whenever you see protocol, it ties to a service, okay? Some type of service for a certain task. And then what protocol is used to encrypt, authenticate, and provide data integrity for RTP? So we want to use secure RTP, SRTP. And then for auto configuration with device version IPv6 addresses to discover its neighbor, right? Such as address of router, that's going to be your NDP, neighbor discovery protocol. Now, depending on the routers too, some routers support specific protocol, like if you're using a Cisco router, they have proprietary protocol for that particular company, right? They create a set of protocols that only Cisco devices use. And then they also integrate universal protocol, common protocol that the industry uses, so that way it can talk to other systems that is not Cisco. So, and so CIS40B addresses that. It addresses like, you know, different routing and switching technology, but most people teach us with Cisco technology, but you have variations with all different technology now. You know, you're not required to just only use Cisco. You can use, yeah.
I did this step.
Pick out the quotation.
Oh.
All right. Now for FTP, we know that it is port 20. So today, when you're scanning with Nmap, which is an active scanner, right? Then you're gonna see port 20, and if you enable 21, it's gonna pop up. I don't think we mask it, but you're gonna see port 21 and 20 popping up for FTP. So to secure HTTP traffic for HTTPS, you would integrate port 443 for HTTPS. And with that, we have to integrate secure socket layer. Personally, I prefer to integrate TLS, which is the replacement of that. Right? The common attack that you've heard, this is maybe a decade ago, it's the Heartbleed. So for the websites that only uses SSL, the older version, they would suffer from Heartbleed attack. Basically, it's a flaw in the way that they wrote the protocol that someone can access the website
It's not,
through the chat. What happened?
I did the correction, but it's not.
Did you delete the pay part? Cancel. Did you make pay part?
Yes.
Okay, add pay part again. Next. If it's not there, go cancel and then go to your users folder and look if you created the account. Any question? Okay, so when we use port 22, we can enable security for FTP. That's SFTP. And commonly, you also see SSH also uses port 22. Okay. So a way that we can integrate FTP securely is to couple it with SSH, hence the SFTP. So port 22. So on Security Plus, right, they are gonna ask you ports and protocols on if you are planning to take Network Plus, which is also a difficult task. You will be asked protocols, network protocols. Okay, so what about the mail servers then, right? We have different types. We talked about the DNS, domain name service. That's the server system that would take the IP, the public IP, and translate it to the URL. So as humans, we go around telling people, oh, visit this website, google.com, right? We don't go around saying visit 8.8.8.8. That's just harder for us to say all the numerical values, right? So they integrated a domain name system where it would take the public IP and tie it to the registered domain name, like Nike.com, right, Microsoft.com, and etc. So it's like registering your home address with the city, right? So the DNS keeps track of that. So for the mail and the webmail protocol, so simple mail transfer protocol, basically it's transferring email between your server and your client. You guys use that every day. You check your RCCD email, that's it, right? They integrate an Exchange server that's allowing it to be able to manage accounts that have inbox and outbox and so on, right? And even when you're looking at webmail, it uses also mail services system where it would be able to tie to the account. But a lot of times mail servers is tied to authentication server because number one, they need to make sure that that's the proper account. Otherwise, everybody receives other people's mail, right? So when you see SMTP, that's port 25, by default, your wireless router turns this off, right? It's turned off. So if you enable that, basically you turn on that service, but we don't enable things unless we use it, okay? Unofficial port, you can also use it with TLS and which HTTPS like Gmail and so on. There's POP3, basically Post Office Protocol version 3. It is a way that we can get also the mail to the server, but you know that server, like when you're using Gmail or Outlook.com, there's not just one server, right? You would have many different forwarding and different type of servers that's in between. So in forensic, whenever we look at this, when we look at Exchange server, we have to look at the mail header. It would tell us like which servers that email actually has. Because sometimes you have to track a piece of email, right? For example, someone committed fraud, they sent an email at this time and you have to track like where it went. because sometimes we have to go to Google, we have to go to Microsoft and subpoena, we have court subpoena material that we have to pull the email from the server because they back it up to get the evidence, right? So, it really tracked like the type of servers. And so with these type of services, you would see that it's using a certain door to be able to pass, right? Your port number. And then different type of servers for different specific, like if I host the Exchange server compared to using Google Gmail host or Microsoft Outlook and so on. And then for MIME, this is multi-purpose internet mail extension. This is a standard that extends your message. So that way you can see pictures and things, HTTP, HTML, you can attach an image, you can add file, you can add, audio, media stuff to it. And so with that, it needs to integrate that into the header. So I tell my forensics student that when you look at the header, you can tell what kind of mail it is already, like where it's coming from, where it's going to, who it passes to, and what kind of attachment you have with that mail, right? And then when we pull it, sometime, if they delete it, right, you can go to the server and find it. And sometimes that takes a long time, but all your data, sometime when it puts to the temp, it puts it on RAM, right? If you guys ever open your application like Microsoft Word, if you don't save it, eventually that space is given back to the system, right? So your software application requires a certain amount of RAM, so it puts it there. And so if your system is alive, sometime we can pull stuff from RAM and we'll be able to see it, okay? Or even temporary storage on the drive, okay? So we talked about HTTPS, which is port 443. Sometimes you see this as 444, but 443. And then your regular HTTP, which is likely very few websites left that uses only HTTP, which is port 80, okay, nowadays. So let me move 14 down. So for 13, we answer that the protocols used for email service is SMTP, IMAP, POP3, and MIME. MIME is actually just standards for the extension of the protocol. And then for 14, RDP, which is for remote location. So I can, you ever use a service where someone can actually access your desktop and navigate, right? Help you configure something. That could be our job one day, right? Many of my students, when they do IT support, they would use some kind of tool that uses remote desktop, like TeamViewer. I'm pretty sure some of you are familiar with that. And so RDP allows the system to connect to the other system desktop. And sometimes you can allow it to take control, like they can take over your cursor and move things around. Now for question 15, it asks you, what is DHCP snooping and how can you implement, how can it be implemented on a network? So DHCP, Dynamic Host Control Protocol, right? Or some people say configuration protocol. This is a protocol that we use to distribute IP address to systems that are connected. It could be an actual server system. At home, you use your wireless router with it, right? When you turn on your wireless router, and then all you have to do is, let's say I have a smartphone, I would connect my smartphone to it, and your wireless router holds a role called the DHCP server. It serves or it provides service to give out IP address to the connected system. Now, in an enterprise environment or a large network environment like RCCD, they would have multiple DHCP servers. You can have it for version 6 and version 4 IP addresses. Now, so along with that, we would see snooping. This is a way that we can implement a system to prevent unauthorized access of fake servers or servers that doesn't belong to that network. So when I taught at a couple other institutions, I would have a rack similar to the back, and I would have switches to have the students connected to the networks. And we can plug that into their main network, right? But it's supposed to loop back. And then sometimes the students, they plug it incorrectly and they run DHCP server. So it was given out like not real IP address for the real network. So let's say they set up a DHCP server and they plug it into that switch and they plug it into the wrong port. It actually circulates it out to the entire company, right? So if that company implemented DHCP snooping, they would block all of those addresses and see that server and then, not send out that traffic to the rest. Because ultimately, they have to be connected to send out traffic. So you need to go back to the users folder that you were previously at. So right click, go to administrative, to computer management console, and then click on users folder. And see if K Park is there. Likely that you deleted him. I can help you in a little bit. Any question? So DHCP server is just a role, right? It could be a role for that particular server computer at home. It is a role for your wireless router to do that. You can configure the layer switch to broadcast only from the trusted ports. So a port could be a logical port, like the number that represents the value for that connection point. Okay, but a port could be a physical port, right? Like if I'm looking at a wireless router, and I'm sure you have this at home, and I take a cable and I connect it to where the Ethernet goes, that's a physical port, right? So on a switch, you would have many of these, right? So the switch's job is just to pass traffic back and forth, right? Like this system to next room or somewhere in the network. And the router is to pass the traffic inside and outside of the network. Like if you have to, get on the freeway to get to the next neighborhood, right? So the router is what gets you to the freeway. Okay. So with that, if we configure the switch to broadcast only from the trusted ports, other things won't pass through. So we basically can filter that through the ports, the logical ports. So when does this happen? If I wanted to take down part of your network, if I can connect to your network, I can put up a fake DHCP server sending out fake IP addresses. And eventually, like let's say half of your employees, their shift is in the afternoon, they come in, right? They're gonna try to connect to, it's gonna get the IP address from the fake DHCP server, and then they won't be able to connect to the network, right? Because it's not real, it's not part of the network. So you're gonna get a lot of tickets saying, oh, I don't have internet, I can't get access, and so on. So we have to prevent things like that too, from the security side, because, anything that's not part of the network should not belong there. So snooping would help you with that. Different between version 4 and version 6 IP address. Version 4 IP has 32 bits. And they are decimal numbers. So decimal are your counting numbers, 0 to 9, 10, right? It is a 10 base number. This is what you learned in math. So stop doing that. Cancel. Cancel there. Right click here. Go to computer management. Local users and group. We did this earlier with users. Double click, this is that. He's not there, so you gotta make him. Make him and then continue with the step where you left off. IP version 6 is 128-bit, right? These are hexadecimal notation. They are 16 base number. So often that you would see numbers and letters, but only from A through F because, you know, it's 0 through 9 and then A through F. You often see the colon in the notation. So when you do ipconfig at home on your computer, your Windows PC at home, it might come up version 6, right? Because your router is configured to give out version 6. Traditionally, I think we're still using a lot of version 4 because people like me, right? We were trained from version 4 and they're still managing the network. So you often see that. And the transition 2011 was when public IP address with version 4 basic that we maxed out, right? Integration for version 6 been around for a long time. But you still see version 4. You just did, ipconfig, it pops up. Kali Linux, you see version 4 popping up. 10.0.2.15, that's version 4. Okay. So I mentioned this earlier for the DNS. It's used for domain name resolution, host name to IP. So Google server, right, the DNS, it would have its name, but it's registered to a domain and then the IP address. So to prevent DNS poisoning, so what do I mean by DNS poisoning? The domain name system contains so many records. It would contain records of how it associated IP to the name. It would contain the reverse record. It would contain the name to the IP and then the IP to the name. It would contain additional information for the domain or any subdomain. So if someone gets a hold of that record, they can redirect, right, all the users to their domain, right? And this you see with phishing attack and a lot of things. So DNS poisoning is a way that they can modify the system or modify the records of that system to lead into other attacks. So we would implement what's called DNSSEC, and this is a security extension. Simply, it validates the responses from the system connecting to the DNS. And it uses a thing called resource record signature to make sure that the record has integrity. And it validates that with the replies. So it checks. And this is simply a feature that we integrated when we configure the DNS, right? You guys will do some of this later. I'll show you how you can install DNS and configure DNS with DNS. So it's a way that we can protect the record, basically, and then validate the replies. Okay, any question? So let's do some lookup for the DNS with our system. Remember that you connected to RCCD, right? That's the domain or the network that we're connecting to. So you can open your command prompt by doing CMD, just like what we did earlier. That's for Windows command prompt, or you can search for command prompt. And this should open. Let me change my configuration real quick. Never mind. So we can do nslookup, which is the next step. So when you do nslookup, basically you're looking for
the domain that you're connected to, or the system is connecting to, and its address, right? Earlier, you saw that when I did ipconfig all, right? It gives me these. Okay. Now you know that there's multiple in the system by looking at this. And we talked about DHCP already, right? They have multiple also. When we did the DNS, it tells me that actually I'm connecting to this one, the 219. Right? So this is the primary for the one that I'm connecting to. Now, depending on, right, I'm on the wireless network, depending on the segment of the network you're connecting to, that could be related to a specific subdomain. So when you're looking at this, how can I tell it's a parent or the subdomain? rccd.net, this is the root right here, is the .net, and then this is the parent. Anything after the dot in front of it is the child. Okay. So when you see like outlook.microsoft.com, that is a subsidiary of Microsoft.com, right? And this is where, and we can have it set up where it carries inheritance and other things, and that will be related to another class. But when you look at this, you can see that it is, right, a subsidiary of RCCD. Any question? So now you know what to look up when you need to do nslookup. So whenever sometimes you connect to a website and it tells you it cannot resolve that website name and you already checked the URL, everything is correct. Sometime it might have the old domain information. So you have to flush it. You have to do a DNS flush and then renew it. And this is what happens when they add or modify DNS. Or sometimes your system have old configuration and it needs to update. Okay. So when you're done, you can just do an exit to get back to your command prompt pop-up. Right? So when you do nslookup, it takes you into the lookup CLI. Command line interface. Okay, so I want to cover a little bit of this, and then we already talked a little bit about the address, but I wanted to touch on it, come back to it real quick because we answered the question. So Kerberos, you're gonna see this again. It uses UDP port 88. It is a way that Windows use to authenticate for Windows domain. So when you log into rccd.edu or when you log on to these computers, it's using Kerberos. It's a way that also protect your passwords, right? But there's no 100% security. Microsoft sworn by this technology. However, you know, it's really how you manage the components for that technology is important. So it uses a key distribution center and it would issue a timestamp ticket. It's kind of like you buy ticket to the amusement park for that day. So the key distribution center is going to give you a wristband. And that wristband is going to tell, right, the staff that works at the amusement park how long you have access to that amusement park. Okay, maybe a day, or if you have annual pass, etc., VIP pass, and so on. So with that, when we integrate this with authentication, you would use what's called LDAP, which is Lightweight Directory Access Protocol. This is a way that we can integrate a service that would communicate with a database where it holds your account, password, credential, privilege, all of that, right? Last week, you did a little bit of permission or privilege control in the local system. But on the server that has your account information, right, like Active Directory, which is a directory service, it would use this protocol to be able to detect what group you're in, what account you have, and so on. Okay. And that's the port number. This is how we can synchronize time. So we know that, you know, now with time change, so you can have it sync properly. And the way that, you know, with system updating, another system syncing is important.
Excuse me, can you help me real quick? I went back and added K-Park. Now,
You gotta get back to where you were before, do that step again. To go to, so minimize this and then get back to where you were. Yeah, there you go. And then redo that step where you add K-Park.
Okay, so IP version 4 addresses, right? The first octet, when you look at this at home or here or on your Kali today, right? You need to look at the first octet. This octet is going to tell you what class it belongs to. When it's 0 to 127, that's class A, right? 128 to 191, that's class B. Most networks, larger networks, they like to use 10 because it's just how we were trained, right? Yeah, you can use 12, 11, 15, whatever, but most administrator, they like using 10. That's just the practice. Class B is this right here. Most of the time you see 176 or 172. And then at home, you use 192, class C. So class C range has the least address. That's great for smaller networks, right? The maximum you can have is 250 systems connected, including your printers, your smartphones, et cetera, right? And the more you have through a centralized point, which is your router, the more congested your network will be. Class B has a little bit more, and class A has the most per network. Okay. So if you have a lot of computers, right? I'm talking millions, we would use class A. So they normally prefer class A to scale because we don't know if a school like this can have like, you know, millions of systems or not, right? And then earlier I mentioned to you about, so this is IP headers. This is how it can know like where it should send it to, which exit it should take it to. The router uses this. Okay, we already talked about DNS and I have a little diagram for you there. So the records I mentioned earlier, right? These are the records that you would see. Make sure we read this part because I know some Security Plus question addresses this. Okay, so we just did 19. Now we're going to talk about quality of service. So, I had like 2 employers that I talked to and they were telling me that they love asking this question. Like, what is QoS and can you tell me how it can be used in a network? Even for security apprentices, you have to know this because network availability is essential for every business. Okay. So simply is a way that we would integrate technologies on the network that would use to measure and control different traffic types based on priorities or operational needs. My example for this is, you know, when you drive or you ride in a car with someone, you hear the ambulance siren and you automatically know because you train or the driver would know to move over, stop, and so let that priority traffic pass, right? So in a network environment, we will integrate system to rank network traffic, depending on the company. So if I am like Twitch, if I'm streaming media, if I have thousands and thousands of servers because people are uploading and sharing your videos and, you know, chatting and all of these things, then my priority traffic will be that because that's my moneymaker, right? Is, you know, or YouTube or, you know, social media type of content. So you prioritize based on your operational needs, and how we can do that is we would be able to quantify the quality that we need, hence the name quality that we need for that network service. So there are tools that can be implemented, but a lot of times network appliances come with TOS capability. So you have to enable that feature and then you have to set up, right, configure it to say, okay, well, you know, when it reaches this bandwidth, right, divert the traffic to other systems. Send it to, you know, switch A, switch B, or router A, router B, and so on, reroute, and be able to get it through so it's not congested. Or when we say, okay, traffic that's ranking 9 out of 10 is gonna go to this system where it's gonna be able to pass fast. So it's like regulating traffic. Not necessarily putting the traffic cop, but being able to have more roadways and freeway for things to get here and there quicker. And the priority traffic needs to get to the right road. Right? Any questions? Let me check on the time. Okay, we're still good. Any questions or anything? So I'm trying to condense networking stuff into one chapter or two, right? But this is a full course. So some of you took 40A with me last time, and it's heavy duty, right? There's a lot to remember. But as you go through security classes or IT classes, we're going to reiterate some of the things. You're like, oh, I remember that we did this, or I saw that, or I scanned this. So it's going to start, we're going to put the puzzle pieces together, and at the end, you're going to see, oh, okay, this is what I need to do. Okay. So who are the entities that assign these things, right? I put down that the port numbers that you work with, that's assigned by IANA. They're international. And then there are register ports. So there are common ports. Those are like the known doors in every house, right? So port 20, we know that it's FTP. So it needs to be like second nature to you. Whenever somebody says port 53, you know, it's DNS, or port 20, it's FTP, or port 80 is HTTP, right? So because you hear it and know it so much that it becomes regular to you. So we need to be like that, okay? So there are some port information here that I put. Sometimes they use uncommon port, like, you know, you would see like 8,000 or, you know, or even higher number, because the security practice now is everybody's using uncommon ports because people are going to scan for the common ports, right? But so to really exit the house, there's only a certain main entrance, okay? So you need to mask it from port to port. So even if they use uncommon port, if you sniff it out, you can find what kind of service they use, right? So ultimately, it is discoverable. So I talked about a switch, okay? So a switch ties to the physical port, and the router routes to the switch. But wait. Some switches are routed, okay? So this is like about less than $4,000 when we first bought it. It's probably $2,000 now. So this is a switch. Its job is to get you to the road in that neighborhood, but it can also act as a route, right? Sometime when you work with voice over IP system, they would use layer 4 switch. That means that it can route and it can do other things beyond route, right? In the layer 4. So we'll talk about OSI later. And then, so the physical ports are these. So how many ports do I really need on a switch? It's really dependent on how many systems that's physically connected. So for a segment like this, I have about 48, 49 computers. I need at least 48 ports, right? If it doesn't fit on one appliance, I bridge the switch, connect the switch to another switch. That's called bridging. So that means that I have one for this side, one for this side. And then connect them together and send them up to the backbone, which is a group of other switches and routers. So ultimately, it's not just all appliances that are connected, right?
And then you sometimes see a smaller switch for the smaller network. So now we can control the actual physical port because they all have numbers. So you can say number 47 belongs to system A, number 48 belongs to system B, and so on. Right? So you map it to the physical system. So in case I walk by, I unplug that cable and I connect my laptop with the cable to it, I can't, right? Because it's not mapped to my physical IP, MAC address, the physical address. And that's because the switch has a table, it matches, right, who to who.
Okay, so MAC filter, you can do MAC filter, so you can set up who's allowed, who's not. The routers connect network to network. Remember that when we're entering and leaving the network, that's the router. That's like the gate to your house, okay? And it doesn't really broadcast. It usually just look for nearby to pass. If you're looking at automated system like, you know, Comcast, Verizon, T-Mobile, they have like tons of routers that would connect quickly. And so they would automate that, right? So, and integrating quality of service to be able to have your traffic from, you know, Moreno Valley connected to someone in New York very quickly, right? But it needs to go from router to router because they don't own all the networks across the United States. You know that it goes from one network to the next network. And so when we do forensic for that, you got to see, oh, where did the system get transmitted to? And sometimes you have to go to multiple vendor to ask to subpoena for that order. Okay. So router deals with IP addresses, protocol ports, and then you can do an implicit deny. You can deny a certain traffic. So this is when if someone is trying to do denial of service attack, right? If you can control that with the router, not just the firewall, we can do application firewall and filter. So you can set up a set of rules for your firewall. When it detects it, it's gonna say, oh, I'm gonna block it and I'm gonna notify other system. But you can also control the router. When it sends this many packets, do not let it pass, right? It's kind of like saying when that car has more than 50 people inside, we're not gonna let it go through. We're gonna check every single one of them. And sometimes just say, no, stop, go away, right? So you can control many things through appliances, okay? And then, so the firewall, we talked about how it filters, there are different types. So when you see the host-based firewall, those are just like application-based. It's installed on that host. And then there's application-based firewall, that's software. Network-based firewall, it detects the network. Stateless rules, it uses permission and it looks at like where it's coming from and the port. There's stateful, where it inspects and make a decision based on content. This is slower. So like I said earlier, right, checking the car with 50 people, yeah, stateful is good for that. So if it you know, the content, and so I tell my ethical hacking class, payload is so important because in that the system, it checks the payload value to look at the length or the size of your data. So if the payload is too large, potentially it could be an attack. So we would inspect it more carefully using the firewall. So that's like your border patrol people, right? They would look at like, oh, who's allowed crossing the border, entering our private network, and who's not. And then the stateless one, it's basically looking at the permissions for that system and where it's coming from. So if the public traffic is coming from China or somewhere else that we don't know, right, just block it, right? We can set up to block. But you know, when you block, you have to keep blocking because they're very resourceful about masking the IP and where it's coming from. You know, if we can use VPN, you think we can't use VPN, of course, right? So we have to up our level with the technology. And then when you're using the demilitarized zone, DMZ, it is just a buffer area between the private network and the public network. So you can set up a logical network that would have some public facing that would allow public traffic, like your web server would receive traffic from the internet. But before it sends it, to the network, it has to go through all of the checkers, all of the detector, all of the preventer, okay? Okay, let's talk about 21. What is used to prevent a broadcast storm, a flood, or a looping on a network switch? So the switch, its job is to get things to a certain segment of the network, certain section of the network. And sometimes it would send to everybody, right? That's called broadcast. So when, like, you listen to broadcast radio, you just send it to everyone in the world, right? A unicast is when you send one to one, and then a multicast is one to a group. So sometime in the case where certain features enable, it would send to everyone, and that can create congestion on your network with broadcast storm or flooding. Or even looping. It's keeping looking at, it's just keep on going, right? Back and forth, back and forth. So we can configure a spanning tree protocol, your STP, or in the newer protocol, it's called rapid STP, to prevent these broadcast storms. So basically, that's simply allowing us to have better throughput traffic. Oh, yeah, you've got it. Okay. All right, no problem. Yeah. Now, as we mentioned earlier about the firewall rule, so ACL stands for access control list, right? Who has access to the network? And a lot of systems have ACL. Your computer has ACL, right? If you right-click a file or a folder and go to, the properties and look at the security tab, you see the access control list. You go on your wireless router, you see who can be filtered or who can be blocked or who can be allowed, right? Deny or allow. So the firewall, you can tell it what to check for, which are the rules. And when it looks at traffic, so in the stateless firewall, remember that it's inspecting based on permission, control, and where it's coming from, right? So that's the stateless. Now you might hear, and interviewers, they love asking this question, right? Or even if you take certification, they might ask you on next generation firewall or your NG firewall. So when you purchase a firewall, you look into firewall, you would see that they're all different. They have different functionality. The category for next generation is basically it does deep packet inspection. And so there are features that it's going to look at what kind of packet it is, not just the size, right? Data by nature and so on. Because it's a good way for it to detect attacks or things that could be malicious for the network. And a lot of these systems now, the newer systems have AI integration. They are intuitive. It also learns based on behavior of the network. So you can enable some of the feature on these systems, depending on, the technology that you buy. Now, some firewall you would go and buy, it's $10,000. That's not expensive. And then if you're looking at something like Palo Alto, it could be a lot, tremendously more, right? And some of their technology, they also have live engineers that work directly with you to help in security management. So some of you might look into getting into Palo Alto, right? Good company, good pay. Any question with this? Okay. And then I'm almost gonna be done with lecture and then I'll give you a break. Purpose of DMZ. So we can create the DMZ to give it a protection layer between the internet and our private network, while allowing connection. When you hear DMZ, sometimes your mind goes to a certain country that has DMZ, right? Like we would see Korea, between Korea and North Korea, or South Korea and North Korea, right? That's an area where you would see. So in DMZ, you would have public traffic still internet facing or internet connected systems, like your web server needs to be there. Sometimes there's would be, you know, some database connected to that web server, or it could be mail server. But you also need to protect those systems on the DMZ. So there's no perfect design in network. I think even with all the concepts that are integrated, the challenge is that, you know, you have to have it available and has throughput, high throughput, but also secured. So network address translation, it takes your public IP and correlate that to your private IP. What you know legally on the outside to the inside, like legal name to nickname. So there is static net. It uses one single public IP for one-to-one mapping private public IP, like your smartphone has that. Right, when you register for that phone number for an account with Verizon or T-Mobile, they associate that phone number to an IP address really. But at home, when you're using your wireless router, you're using dynamic net because there's only one public IP address for all the system you have at home. In a lot of networks, they use dynamic net. Because, you know, when we establish the service, even for the business, they would give us maybe one or two or a few public IP addresses for your networks. And then you would use that, right, for the router that's facing, because the router is connecting you to other networks. And then everything else is going to use that IP address. So it funnels through that one public IP. So NAT does that, and there's two types. So at home, when you're looking at Whois, you guys know how to use Whois? So, if you open Google, and then you can find Whois website. A lot of the companies that does like domain names and stuff like GoDaddy, they would have Whois. So you can look up a domain, right? Microsoft.com. So on that, right, see how they blocked this? You can't find the information you used to be able to. So they can secure this. And then if you take ethical hacking, you know why. Because we get the banners and that's how we're able to get in, right? It would tell you like information about how that domain is registered or what kind of public IP that a certain system have. Okay. So when you use like your network scanners to test your traffic at home to see if you have throughput, a lot of times it's checking your public IP address, or when you're using a Whois system like this, it would also find like what's registered to that IP address. Okay. And you can also use ipconfig. And when you use who is, right, especially in ethical hacking, that's just a passive way to look for information. Okay. So we talked about static and dynamic net. And then for proxy, so proxy can be many things. It can be a way that we can pass all the traffic to that particular system for monitoring. It can also act as traffic police. There are many things that we can use proxy for, but for the non-transparent proxy, it would accept, forwards, and modifies the request based on the rules. So basically, you're setting up a rules on that system, and all the traffic has to go through that system, right? And then it's gonna look at, oh, system A is requesting this, but not meeting the rules, so it's gonna modify that or reject it, right? And then sends it through. In order to send it through, it has to modify it, okay? So that's a way that you can use non-transparent proxy, but proxy can also be used to make your traffic have more throughput. So instead of going through 1 or 2 filtering system, I can set up 1,000 system, and then I would allow my client system to connect to those depending on the traffic. Remember, we talked about quality of service to get traffic to certain places quicker. But proxy can also be a way to bypass things too. So if you use it for protection, you always know that there's always the opposite side of it. Okay, any question? Okay. On your system, Wireshark is already installed. So for today, we're just gonna scan the network real quick. Oh, I know that on my system, they didn't resolve that yet. So on your computer, search for Wireshark and then click on the app. So you can download this. This is open source. You just need to install npcap. That means that it's a listener. It's gonna be there. I'm on Wi-Fi only, but you need to click your Ethernet adapter. You would see the little graph line. So don't click the virtual box or the other ones. Okay. And no, yeah, close the install updates. We don't have the privilege to do that anyways. Yeah, so click the adapter that you would see the little graph line, and it would say on yours, it would say Ethernet killer, whatever, right? That's the adapter that you use. And then you're gonna click the blue fin on the top left, or you can also say capture or start. Okay, so select your interface, how you connecting, and then click the blue fin. Yeah, Ethernet for you. I'm on Wi-Fi only, so my laptop doesn't have Ethernet adapter. So what you're gonna do is you're gonna let it go for, a minute or so, right? So these are all the conversations that the systems are communicating, and we're talking about everybody, your computer, my computer, right? The switches, the routers, the computer next door, someone down the street with their smartphone, right? That's connected to our network. And you see there's UDP, right? Sometimes you would see TLS. Okay, we can stop it. A quick way that you want to, and they're color coded, right? We'll do a lab with Wireshark. I did this with my other security classes already. So they are color coded based on the type of traffic or the type of protocol. You can click the source to sort out all the same type of system. This is a quick way for us to identify, because when you have 40,400 computers, right? It might be really difficult to pinpoint. You can also scan a certain system by its IP address on the network. So it tells you for that step, you just click start, click the blue fin, and then for a minute or so, click stop. you're gonna sort it by the source tab. So when you click the source tab, it shows a little arrow. That means you're sorted. So you would see the same traffic for that system, right? So that can help us narrow down like that system is doing what, okay? And then on the bracket on the left, you might see the little bracket on the left of the number here. Basically, it includes, that bracket tells you that that's the inclusion of all the conversation for that system. Okay. And then anytime that, so let's say that I want to look at the UDP traffic for this one, and yours look a little different because we're on a different segment. And then you can always double click. And then on the arrow, you can expand it. So you can see the frame, the Ethernet information, the addresses, right? These are all the header stuff that it pulls. Since I'm on a UDP one, it shows me the source port, the destination port. Those are the doors the system used to communicate. And then the length, the checksum. So it needs to do a checksum to kind of make sure that everything is intact. And then some of them would have timestamp, but the payload, remember what I said earlier, the size. So you will have different sizes in payload depending on the packet. So take a screenshot once you look at the first packet. And then you can expand like what I said. You can find the destination and source address or destination address where it's sending to. If there's header length information, you can include that. Okay, so let's go back here. You don't have to pick the first one. So my destination port, it shows me that because it's a UDP, it's sending to 8801 port, and it's coming from 50155 port. But if you wanted to pick, let me see, let's go back and pick something more interesting. Here's the ping one. That's the ICMP. I have a ping packet. Destination unreachable. So you can check out some packets. The destination, this one I have a version 6 address. And this is a Cisco device. So some vendors, they would use their name onto the actual physical address, which, you know, it's easy to identify. And then you can find a TLS one you want to look at. This is a TCP. So TCP, this is, you know, TLS is going to tie to HTTPS. So secure website right here, right? There are 12 in a total conversation. Gives you segment length. So TCP is going to give you more details, like sequence for acknowledgement, and then payload size, and so on. Okay. If you pick so for question I, make sure that we click on one that has TCP, like I did with like I found a TLS one. I think that's like a light pink or light purple. You can also sort it by protocol and then find the TCP one. So once you find the packet information, put down the information here. if you use a TCP, right, there are SYN and ACK packets, right? Synchronization or acknowledgement. And so you might be able to see it, right? Like, for example, this one is an ACK. That's an acknowledgement one.
Where's the data per length?
My app just crashed. That's why I needed to upgrade.
Funny. Yeah. So. Let's try using like a TCP one, so it's easy for you to scroll down. There's a TCP. Yeah, and then remember, just expand the arrow.
We saw that in 48. Okay. Any question? Sorry, my Wireshark app just crashed. And you would be able to find acknowledgement number. So it's a value that's used for that acknowledgement. And then the sequence number. Because remember, we talked about packets being data, transmitted data is being broken up into different pieces. So it needs sequence number to put it back in order. Like your bicycle, it has to go from, you know, we would put the handlebar and the frame and then that. Yeah, you want to put the handle. Yeah, because you're using a datagram packet, so you don't have the TCP. So go back to your Wireshark. The bin. And then you click on protocol to source it. And then scroll down and find the TCP section. Click on source. Right, any questions?
How? We go this way and that. Yeah, so let's pick one. Let's pick a protocol. Let's pick one. And then find. One of those. So source destination, click on internet protocol. It gives you additional information. The IP. Click on the internet aid. Well, it's best to probably see the TCP one that gives you more information. Yes. Scroll down, its T is all the way in the back. They send it. So there you go. Pick them from one of the. Yeah. And if it's SYN, act both, because, okay, so the client, so if I'm sending to you the acknowledgement that I'm sending, and then the system, so I say, hey, are you ready? And you say, okay, I'm ready, that's acknowledgement. And then I'm gonna say, I'm ready to send, right? And then you acknowledge back with a thing saying no, accepted, right? You see. Yeah. Okay. Other hands, other questions?
While we're doing that, I'm gonna stop recording.